Okay, so here's page 2. Check your work with mine. My first step here is, of course, to add 54 to each side. 16x to the negative 3/4 power. That's my fourth root of 16x cubed. I'm going to go ahead and multiply everything to the 4th power. That cancels out that fourth root, leaving me with 16x cubed. And then, of course, I need to take the cube root of that on both sides. If you had wanted to, over here while solving, you could have taken 16x to the 3/4 power equals 64. You could have multiplied both sides of the equation or raised them to the power of 4/3 and had these two fraction exponents cancel you out, leaving you 16x is equal to 64 to the 4/3 power, which you can then go ahead and simplify. Your final answer is x is equal to 16. And when you check that, you'll see that that is a good solution up here. You'll see that I included a check because I'm still nervous about those extraneous solutions. I don't want to miss out on those. All right, our first step here is, of course, to add 3 to each side. Then I went ahead and multiplied both sides by 2, leaving me just my exponent on one side of the equation and then 8 on the other side. I rewrote it as a radical, and then I took the 4th power of both sides, leaving me with the cube root of 3x minus 1, or 3x minus 1 to the 3rd power, and then I took the cube root of each side. That left me with x is equal to 17/3. When I go ahead and check this one, I want to make sure that I substitute my value in for x. 1/2 times 3 times 17/3 minus 1 to the 3/4 power minus 3, and I want that to equal 1. So when I go ahead to my calculator and I type that in, I have 1 divided by 2 times 3 times 17 divided by 3, and then that's minus 1, and I close my parens, and all of that is to the 3/4 power. And we're going to go ahead and see, that doesn't look right. So let's go ahead and break that down. 1/2 times 3 times 17 divided by 3 should have been equal to 17 minus 1 to the 3/4 power minus 3 is equal to 1. Oh, I wonder if I forgot my minus 3. Shouldn't have made a difference. Let's see how that worked. One half times 17 minus 1 to the parentheses. There I go. 3 divided by 4 power. Need those parentheses there. Minus 3. And now I get 1. Yes, it definitely checks. Okay, so for 11, I'm going to go ahead and take 1 square root and add it to the other side. When I add it to the other side, then I'm able to square both sides. When I square both sides, both of those radicals are eliminated. X plus 4 is equal to 2x minus 8. Add 8 to each side, subtract x from each side, and I get x is equal to 12. And of course, I'm going to take the time to put it back into my check and make sure that it works out. For number 12, I'm going to go ahead and square both sides right off the bat to eliminate this radical. I'm nervous because this has a negative x, and again, taking the square root of a negative value and having that give you that negative is not really possible in mathematics. So my math still works out, and I can still go through. I get a quadratic that I can factor, and I end up with that double root of x is equal to 1. But I'm still nervous, so I absolutely check, putting 1 in here, and I do not get something that's true. Since I had no other solutions to check, that just means that x is equal to the empty set. There's no solution, and this one here is an extraneous solution, so I cross him out. Number 13, we'll let you take a look at that. I square both sides. Keep in mind, whenever you square an algebraic expression, those parentheses protect that subtraction or addition that comes first. So that's the same as our perfect square binomial, and I want to make sure that I FOIL to get everything multiplied by everything else. When I have a quadratic, I solve a quadratic by setting it equal to 0. So I'm going to subtract x from each side, and then I'm going to add 7 to each side. I factor it, and these both solutions are checked. I checked 8 in this one, I checked 7 here, so they're both good solutions, so we list them both as our answers. For number 14, subtract 3 from each side, square each side. My radical is eliminated, but keep in mind that this now I have to FOIL, leaving me with x squared minus 6x plus 9. Combine like terms when I subtract the 5 x's. I'm going to add 1 to each side because remember, as a quadratic, we solve quadratics by setting them equal to 0. Always going to look to see if we can factor. Luckily, in this one we can. We get two values for x, positive 10 and positive 1. When we put positive 10 in, this one checks, so that's a good solution. When we put 1 in, unfortunately it doesn't check, which means that this is an extraneous solution and it doesn't count. All right, good job on the homework. Keep working hard and ask questions. Fill out your reflection.